Hello everyone, this is our chapter 6 for core Java. What we are going to discuss in this video is about literals, and we will discuss about Java variables. We will discuss about type conversion and casting. Then we will discuss automatic type promotions in expressions, how they work, and then we will discuss about arrays. So let us look at first about literals. So literals, as I hope you remember from our last video, they are the constant values. And integers are of 5 types. First one is your integer, second floating point literals, third is boolean, fourth one is character, and fifth is string literals. Now let us look at closely when we say integer literals or floating point literals, what is the difference between them? Now, integer literals, they are basically whole number. It can be a whole number, 10 or 15, 25, 30, any integer value. And integer literals, they are the most commonly used type in Java. And the decimal value for integer literals, they have a base of 10 number. There are two other bases also used when we say integer literals. They are octal and hexadecimal. Octal has a base value of 8 and hexadecimal has base value of 16. Now, how you will denote an octal value in Java? So, octal values, they are denoted in Java by a leading 0. So, decimal number in pure itself with a base 10, they cannot lead with a 0. Remember that. Any number, if it starts with 0, that is going to be an octal number. But again, octal has a range. So let me show you what's that mean. We will open our IDE. Here is our IDE. And now let me define integer. I will say A is equal to, I will just define 7 and all good. Now we know that this variable A is of int type and the assigned value is 7. Now this is base 10. Now if I want to make it a octal value, I can just put a 0 in front of that. So that is still valid because octal, the range is from 0 to 7. That is 8 number octal. If I will go beyond this range, if I try to type it over here 8, see what will happen. Now we are getting error and it says the literal 08 of type int is out of range. Because 08, that is out of range of octal. What we are saying is that this particular number is an octal number, but this is not an octal number because it is out of range. The range for octal is 0 to 7. Now, let's go back and fix this one. It's all good. And let's get back to our PPT once again. So octal values, they are denoted by a leading 0. Hexadecimal values, hex, basically as we said base 16, they are denoted in Java with either a leading 0 and capital X or 0 and lowercase x. So and I will show you, we will do actually, one another line to show you basically how it works. Now, the most important thing what we need to remember is that hexadecimal digits, 16, they go from 0 to 15. And 0 to 9 is 0 to 9. But from 10, 10 is basically, we consider it as either a capital A or lowercase a. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is S. Now, integer literals create an int value, which in Java is 32-bit integer value. I hope you remember that int, they are 4 bytes. That's mean 32-bit. We can assign integer literal to byte or short without any mismatch error until literal value is within range of that target type. I already shown you this in our last video. I will show you once again that unless we are in the range of byte or short, int value can be assigned to byte or short without any mismatch error. And integer literal can always be assigned to a long variable, right? There is no doubt in that one, because long is double the size of int literal. So we can definitely assign int value to our long variable. The only thing what we need to do is, if we know that our value is long value, and whenever we are trying to assign, whenever we want to tell basically to the compiler that this is a literal type, long type literal, we always have to append that with either a lowercase l or a uppercase l. For example, over here you will see that it starts with 0x, which tells us right away that it's a hexadecimal number, and then 6, and then F, 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 and then at the end, if you see over here, it is L, which means that this is a hexadecimal number and it is long variable, assigned to a long variable. The next one is integer value can be assigned to a character value. You've seen that already in our last video. As long as, again the same condition, as long as it is within the range. You can also specify integer literals using binary. So if you want to assign a binary value to int, we can do that. A binary value always starts with 0 lowercase b or 0 uppercase b. Now let us try these 3 things now. So first of all, we will see how to assign hexadecimal. Then let us see how to assign binary. And then we will see how to assign, you already seen that, I will show you once again, int literal to character value. So let us look at this one. I will go back to our IDE. Now let me simply change this one. So remember that octal starts with 0, but hexadecimal starts with 0, x. Now I can, and for hexa, it is 0 to 15, and there is no issue with that. So we declared int as a, and we are assigning a hexadecimal number. Now if I have to assign a binary number, what I will say, int c equal to 0 b, and then I can assign 0, 1, 0, 0, which is basically for number 4. So this is how you assign a binary value to your integer literal. And now the next one is character. I will just define one variable ch, and I hope you remember characters, they are 2 byte longs, and what I will do is I will assign, let us say 1000, and here we go. You just need to remember basically the range, that you are not going over range. If I will try to assign over here, it just shows us right away that there is an issue. But if I will make it in range, then we are all good. Let's go back to our PPT once again. So this PPT, this particular slide was the discussion of integer literal types. I hope it's very easy. Just to remember all this, that decimal, whenever there is a decimal value, its base is 10, octal value base is 8, and hexadecimal base is 16. Now let us look at, continue with the integer literals. So it says that you can embed one or more underscores. You've seen that in our last video again, that we can define our integers by using underscore. I hope you remember that. And the underscore, they will be simply ignored. Underscore can only be used to separate digits, okay? Now there's a condition, they cannot come at the beginning or end of a literal. So you cannot start a number with an underscore, and you cannot also end any number with underscore. That's a problem. It will give us basically error that you can't do that. It is invalid. It is, however, permissible for more than one underscore. You can definitely use more than one underscore between numbers. So if you want to say 1, 2, 3, underscore, underscore, 4, 5, 6, underscore, underscore, 7, 8, 9, it's all good. No, it's not an issue at all. Now let us look at floating point literals. As you know that floating point, they represent basically decimal values, fractional component. They can be expressed in either in standard or scientific notation. Standard notation consists of a whole number. Now standard notation, you remember that 7.0 or 3.14159. It's a fractional number basically. After decimal there is a fraction. Or it can start with 0.6687, represents standard notation floating point numbers. And in scientific notation, uses a standard notation, floating point number plus a. So over here, this is basically exponent. Exponent is indicated by either capital E or lowercase e. So if I have to define this number, and what that means is, it's basically over here. So it specifies a power of 10 by which the number is to be multiplied. So over here we define 6.021 exponent 23. 314159 exponent minus 0.5, so that we can bring the decimals. 2 exponent plus 100. Now by default it is plus. Floating point literals in Java default to double. I hope you remember that floating point by default, they are double, so it's a double precision always. To specify a float literal, you must append an F, capital F, or a lowercase f to the constant. This is basically we discussed actually in our last chapter also. Same thing. Again, same thing. What we can do with our integer literals, we can do with our floating point literals also. You can embed one or more underscore in floating point literals, and it's pretty valid. Now, let us discuss about Boolean type of literals. I hope you remember again from our last video. In Boolean there were only two values, true and false. So there are only two logical values in Boolean, true and false. The value of true and false do not convert into any numerical representation. Remember that sometimes, especially whenever, if we are coming from a different language where true was actually 1 and false was 0, It's not true over here. The true and false, they do not convert into any numerical representation. And Boolean literals, they can only be assigned to variables declared as Boolean. They cannot assign to int or float or anything else. It's only going to be Boolean or used in expressions with Boolean operators. We will see that in our next upcoming videos. We will see how to use them. Now the next one is character literals. As you remember, 2 bytes, they are 16-bit values, and they can be converted into integers and manipulated with the integer operators. We already seen that. In our ID also we typed one program, and we used basically one addition operator, and we then printed basically the numeric value. So we can do that. A literal character is represented inside a pair of single quotes. I hope you remember that it was like simply single quotes. For characters that are impossible to enter directly, there are several escape sequences that allow you to enter the character you need. So let us say that I want to print just a single quote. How you will do that? We will use actually a escape sequence and then single quote. And then whenever compiler will look at that, it will simply ignore this one and it will consider only this single quote. And this is for the new line characters, N. Now, it says that there is also a mechanism for directly entering the value of character in octal or hexadecimal. For octal notation, use the backslash followed by a 3-digit number. So this is how you will do the octal notation, backslash and then your 3-digit number, that is octal number. And this octal number represents what? A lowercase a. And for hexadecimal, what you do is you type backslash u and then exactly 4 hexadecimal digits. So we are saying backslash u, which tells right away that this one is hexadecimal, and then the 4 hexadecimal digits. Now, string literals. String literals, they are represented between double quotes. And example you see over here, hello Java, and it is in double quotes, starting quotes and ending quotes. Over here, what we did is it's a string, and we are using new line, 6 n lines. And over here, we are using basic. We want to print this is in quotes. How we will do that? We will use again this backslash and then quotes. So compiler will ignore this one and it will print in quotes. This is in quotes and then quotes, and it will ignore this and this one. So this is basically string literals. Now let us discuss about variables. We already used them. Once again, let us see that what is the definition. A variable is defined by a combination of an identifier, a type, and an optional initializer. So if you define int a semicolon, that is, you simply define that, okay, this is the identifier, this is my variable. And if you initialize it with a value, then you can also do that. The important thing what we need to learn and remember over here is that all these variables which we create in our source code, they have a scope. And that scope defines their visibility, that where they are going to be available, and once you go out of one method, let us say, or out of their visibility, you cannot use those variables because there is a lifetime for those variables, and we will see what that means. Now, how to define? You already seen that, you already practiced that by typing a program in IDE. Once again, let us look it over here. We are defining 3 int variables over here, int a, b, and c. Declare 3 ints. Over here, what we are doing is we are saying int d is equal to 3 and then comma e. Over here we initialized it. We initialized this one, but we did not initialize this one. Declare 3 more ints initializing d and f. Byte z is equal to 22. Initialize z. Double pi, we initialize that one. And over here, this is how you initialize the character. Now, sometimes over there we initialize couple of variables, but initialize can happen actually at a dynamic level also, at a runtime also. How that happens? So let us read this. It says Java allows variable to be initialized dynamically using an expression valid at the time the variable is declared. For example, look at this program. This is our first program. Now I define one variable a of double type 3.0 and then there is another variable b is equal to 4.0. Now what I'm going to do is let me copy and paste the whole program. I will simply gonna paste it over here. Now I started with double a 3.0 comma b, which is automatically because we defined it over here double, so b is also double type and 4.0. Now whenever we will run this, right now if I just look at over here, I initialize the value of a over here 3.0, I initialize the value of b over here 4.0, but I did not initialize value of c over here. This value c will be initialized once we will run this program. So what will happen is that runtime 3.0 then 4.0, it will add and then this will go to c, and this is how c will be initialized. So let us run this one. Okay, 7.0. So this is what we say dynamic initialization. During the runtime, c is initialized. As soon as we executed this one, it is initialized and it printed the value 7.0. Now the key point here is that the initialized expression may use any element valid at the time of initialization, including calls to methods, other variables, or literals. Now, what's that mean actually is for right now, just remember that it can happen by calling method or looking at other variable or other literals, and we will see that how dynamically by calling a method, a variable can be initialized dynamically. We will see that. Now this is very important for us to understand scope and lifetime for variables. Now remember that all the Java programs, we start with curly braces and we end with curly braces. And in our program so far, we've seen that, let us go back and so this is one block basically, class welcome, and then this is our first method, and this is our initialization of second curly braces. So this is one block, this is our second block, and now we did something, we printed it, and now we closed this one. So this closing curly brace is for this one, right? This is one block, and then the second curly brace is, it is for this one. So this is our first block. Now where we define something, that matters a lot, and we will see that now. That is what actually that PPT, that point over here, what it says is Java allows variables to be declared within any block. A block is begun with an opening curly brace and ended by a closing curly brace. Now a block defines a scope. Thus, each time you start a new block, we are creating a new scope. So every time we start a new block, it is basically a new type of scope we are going to have for the variables which we are going to define actually in that block. And what's that mean? We will do one practical and then it will be crystal clear to you that what's that mean. Now, a scope determines what objects are visible to other parts of your program. And this is basically the definition of one of the basic principle basically that hiding data from outside world, encapsulation. That is what is happening over here also. Now, in Java, there are two major scopes. One is defined by a class and second is defined by a method. The scope defined by a method begins with its opening curly braces. As a general rule, variable declared inside a scope are not visible that is accessible to code that is defined outside that scope. What's that mean? We will see that now. Thus, when you declare a variable within a scope, you are localizing that variable and protecting it from unauthorized access and or any modifications. That is the one of the major object-oriented principle to hide, to save basically our variables from outside. Scopes can be nested. For example, each time you create a block of code, you are creating a new nested scope. When this occurs, the outer scope encloses the inner scope naturally. So you started one curly brace, you define a couple of variables, and then you start another curly brace. Now the outer block, that is basically the parent. So the outer scope encloses the inner scope. This means that object declared in the outer scope will be visible to code within the inner scope, but vice versa is not possible. However, the reverse is not true. Object declared within the inner scope will not be visible outside it. Now, let us quickly look at this. What's that mean? Now, this is my class. This is where I started actually my class. Now, if I try to access A over here, if I say now right away it gives error. It says because this one is not visible. This is our first block, and then we started the next block, and this is class, this is a method. So this particular variable is not visible over here. And now if I do this, let me actually we need to create another method. We did not done that so far. Maybe in next chapter I will show you what that means. Now let me define a variable over here. So I need to define, because this is a class variable. So first of all, let us try to declare a variable simply, and I will say class CL var, just defining any name, or let me give it a simple name, CL, and I say 15. Now let us try to print that over here, and I will say CL. Now it says right away cannot make a static reference to non-static. Now this is something different for right now. Yes, I will put static, and we will discuss that why we have to do this static. But right now, just to remember that this is our parent, and in parent class, then this method started. So I defined one variable over here, CL. Now that variable, if I run it, it will print that. So this parent variable is visible in this method, which is child of actually this class. But this particular child variable, it is not visible over here. So that is the definition what we just discussed over here, scope and lifetime. And we will, in the next coming videos, we will see all these, what we just discussed over here, all these points in detail, that what's that mean actually, how they work. And what is the advantage that, there is a scope, there is a lifetime of these variables, how encapsulation works, and what are the advantages of encapsulation. Now, next one is this another example over here. So we started one class, and this is our method. I define one variable over here. So in this method, known to all code within main. So main is our method over here. So this X is visible to all code within main. I initialize, extend. Now we did not done so far if condition, but for right now, just look, what I'm doing is I'm comparing. If X is equal to 10, then I'm starting a new scope and then saying int Y is equal to 20, known only to this block, because this is another block I started, and this value of Y, it's not visible over here. It will be visible only between the start and end over here. And now if I will try to assign Y is equal to 100, that Y is unknown here because the scope is ended over here. Where Y was initialized? Over here in this scope. Now Y is not visible here. So if you will try to reassign any value to Y, it will say simply Y. I don't know what is Y over here. X is still known here. Why? Because X is starting basis over here and ending over here. So X is still known here. So X, it will print the value, and now we are ending actually our class scope. So the thing what we need to note over here is that variables are created when their scope is entered and destroyed when their scope is left. Now, although blocks can be nested, you cannot declare a variable to have the same name as one of an outer scope. You can't do that, remember, because the outer variable that is visible to the inner, remember that, right? So if this is my opening braces for this method main, I define one variable bar is equal to 1 of int type. Now I started another braces and I'm saying int bar 2. You can't do that. You already defined that. By just starting a new braces, still you inherit actually that bar over here. So you cannot again initialize that. You can assign a number, sure, but you cannot initialize that again. So that's our issue. I will highly recommend to type these programs so that you can understand better what we are discussing in these slides, and it will be more clear. And in next coming videos, we are going to do more and more coding, then it will be more and more clear to you what's that mean whenever we are saying scope and lifetime. We will see that. Now let us discuss about type conversion and casting. Casting, you already seen that. Now it says it is fairly common to assign a value of one type to a variable of another type, especially if the condition is those two types are compatible. I hope you remember that we can assign any byte, any short to int, or we can even assign int to byte or short until unless we are not going over the range. We can do that, and Java will perform the conversion automatically until we are in that range and everything is good. Then Java will do that automatically. Now, but I hope you remember that one time what we tried is we said byte b is equal to 10. So let me do it over here again. So I will define byte db is equal to 15. Now this is all good, right? Even this is happening automatically. Even this is actually a int value, but because this is in the range, we are all good. That's what it means, that this conversion will happen automatically. Java will perform the conversion automatically. And this automatically conversion, we say implicitly conversion, automatic conversion. The two types are compatible. These are the conditions. The two types should be compatible, and the destination type is larger than the source type. Now, casting incompatible types. There is no automatic conversion defined from double to byte. To do so, you must use a cast, which perform an explicit conversion between incompatible types. This kind of conversion is sometimes called a narrowing conversion, since you are explicitly making the value narrower so that it will fit into the target type. Now, what that means is, let us look at this. So, let me define one variable float, and I will say fl, and I say 135.567. Okay, now why? Because this is double, so I need to float. We are all good here. Now, if I need to convert that into, let me try int, I will say, well, int is equal to, and then if I try to do f1, it will generate an error, and what it will say is f cannot be resolved to a I type f1, it is fl. Now that's a problem, type mismatch, and now what we need to do is we have to do casting. I will say int, and we are all good now. But now what will happen is, as soon as we will do the casting, this was the float value, we will just get only 135. Let us try to print it. And I'm not gonna say sum, I will simply say well int, and that's pretty much. So it printed 135. Let's go back to BPT. Now, I think we discussed this one. Yes, the next one is this one. Now, to create a conversion between two incompatible types, you must use a cast. A cast is simply an explicit type conversion which has a general form. We seen this how we did casting. Remember? So over here, a is int byte b is equal to byte a. You've seen this. A different type of conversion will occur when a floating point value is assigned to an integer type, truncation. You already seen this one. Please type this program and try it out. Now, automatic type promotion in expressions. Now, this is important to understand because most of the time these are the mistakes what happen, and hard to catch actually these type of issues. So in addition to assignment, there is another place where certain type of conversion may occur in expressions. In an expression, the precision required of an intermediate value will sometimes execute the range of either operand. For example, okay, let us look at this example. So over here, the value of byte A is 40, byte B is 50, byte C is 100. Now int D is equal to 40 into 50. What's going to happen? That will be 2000, right? Now 2000 and divided by 100, so no issue, and it is printing 20. Now Java automatically promotes each byte, short, or character print to int when evaluating an expression. As useful as the automatic promotions are, they can cause confusing compile time errors. So over here, what happened is in this program, basically 40 multiplied by 50, 2000, which is more than the range of byte, but because automatic conversion happened to int, that's why there is no issue at all over here. And this is automatically conversion. But now let us look at our second example. I will simply copy paste this value over there and let us see what happens. So I define one variable b is equal to 50 and then b is equal to b into 2. It looks like that there is nothing wrong over here, right? Because what we are doing is even 50 multiplied by 2, it comes still 100, which is still in the range of byte. But because of this int value we are trying to, we are multiplying int value with a byte value, and then we are trying to put a bigger int value into byte value, where that is the issue. So it says cannot convert from int to byte. So we need to be very careful that this variable where we are trying to put it, it is bigger than our operands. So in the first one, that was the reason that we were simply multiplying two byte values over here, and it was going actually into int, so that automatically conversion was possible, so it did not give us any error. But in the second scenario, what is happening is byte into int and trying to put it back into byte. That's a problem. That's the issue. I hope that's clear. Next. Hypermotion rules. All byte, short, and character values promotes to int automatically. If one operand is long, the whole expression will promote to long. We've seen that one was byte, one was int, so the whole was promoted to int. And if one operand is long, the whole expression will promote to long. If one operand is float, the entire expression will promote to float. If any of the operand are double, the result is double. Now, let us look at arrays. Array is a group of like-typed variables that are referred to by a common name. If you are not familiar with arrays, this is, we just gonna, you can say that this is just a little introduction over here. We are going to type at least 10-15 programs on arrays, at least. So it will be pretty clear to you, because this is very important to understand about arrays. We use them a lot. But right now, for this video, just consider this as an introduction. So array of any type can be created and may have one or more dimensions. They can be one-dimensional, they can be multi-dimensionals. And a specific element in array is accessed by its index. So I want to put, let us say, 10 names, 10 names, strings. So I will create actually a string type of array which will hold 10 names. Always in array, the first value, so consider it like there are 10 boxes. If we are creating an array of 10, that is, we are creating 10 boxes. So in the first box, the first name will go. And the name or the value of the first box is 0. So if there are 10 boxes, the index of those boxes is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Not 10. Remember that, because we are starting from 0. Now we are defining one-dimensional array over here, which says int days, and this is square brackets. This is how you define an array. It says that days is an array variable. No array actually exists. We just defined it over here. To link days with an actual physical array of integers, you must allocate one using new and assign it to days. New is a special operator that allocates memory. We will learn about that also. So over here, this is our array variable which we defined over here, and then we will say new, then type, and then size. For example, over here, days we define over here, and then we are saying new int 12. So what we are saying is that days is a one-dimensional array which can hold 12 values starting from 0 to 11. Let us look at this example, and I can actually type this in. And what is the name? Array. This is our second program, and I will say simply okay, and I'll simply paste it over here. So what I did is exactly same thing, nothing different from what we did before. I just want to make it clear to you what is happening here. And then we are printing. Now, what we did is we defined that days is an int type array. Right now we did not define initialize anything over here. Now what we are saying is days is equal to new int 7. What we are saying is that days array will store 7 values, and the first value is starting from 0 and it holds the value 5, then the first one 10, second is 8, third one is 17, like that way. And if I want to print the fourth value, I will say days 3, and if I run it, just proceed it, and 17. So it simply printed this index value, which is 17 over here. And I can simply close this one so that we don't have anything. Okay. Now, if I want to print the first one, first value, I will say 0 and print it. 5. The first one. Now, if I will try to go, if I defined over here 7, but remember the index is 0 to 6, but what will happen if I try to do 7? Now this is important. It says array index out of bound exceptions, out of bounds exception. So because it is out of bounds, we have only 0 to 6. We are trying to read something out of that range. And we will learn about these exceptions in later videos. But remember that if we define size 7, we can do only up to 6th index. Let's go back to PPT. Array can be initialized when they are declared. An array initializer is a list of comma-separated expressions surrounded by curly braces. We will see this one. The array will automatically be created large enough to hold the number of elements you specify in the array initializer. There is no need to use new. Now what's that mean? Class, we defined array, and remember, now this is a different way. What we are saying is int, days, array, and then we directly putting the values. 5, 10, 8, 17, 21, 6, 9, and 3. So Now automatically it will say, okay, 1, 2, 3, 4, 5, 6, 7. So it will, oh sorry, 1, 2, 3, 4, 5, 6, 7, 8. So it will automatically going to create an array which will hold 8 values. And now whenever we will try to print days 3, 0, 1, 2, 3. This is index. So 0, 1, 2, 3. It will print 17. Now it says Java strictly checks to make sure that you do not accidentally try to store or reference values outside of the range of the array. You see in our last run that it generated an exception that we are trying to go out of range. The Java runtime system will check to ensure that array indexes are in the correct range, and 0 to 6 for days. Over here 0, 1, 2, 3, 4, 5, 6, 7. So it will be actually 0 to 7. In the last example it was 0 to 6. If you try to access element outside the range of the array, negative numbers or number greater than the length of the array, you will cause a runtime error. You just seen that. Now that was one-dimensional arrays. Now let us quickly look at multi-dimensional array also. So multi-dimensional arrays are actually arrays of arrays. To declare a multi-dimensional array variable, specify each additional index using another set of square brackets. So if I have to define two-dimensional array, so this is the first one, this is my second, and I'm saying 4 by 5. So this is the two-dimensional arrays. There is a second form that may be used to declare an array. Over here, remember that in our over here we put our square brackets over here. I can put these brackets over here also, like over here, type brackets and then variable name. It's the same thing. Here the square brackets follow the type specifier and not the name of the array variable. For example, the following two declarations are equivalent. So if you define one array like this, int a1 or al, a new int, you can also define it like this way, a2. Now the brackets are in the front. It's same meaning, no difference. Just you can use exactly the same thing. This is just a second array we defined, but in a different way. The following declaration are also equivalent. We define this one or we define this one. This is two-dimensional arrays. This alternate declaration forms offer convenience when declaring several arrays at the same time. For example, if I want to, so I don't have to put bracket in front of each and every one. So whenever we want to create multiple arrays, I can simply put these brackets in the front and then just the names. Now it will create 3 arrays for me. So it will save me 4 keystrokes. If I will do it other way, I have to do int nums, bracket, bracket, then bracket, bracket, and bracket, bracket. Like this one. I hope that's pretty clear. Don't worry if it's a little confusing right now. We will do. Now in the second chapter, in the next chapter, what we are going to learn about is arithmetic operators. In arithmetic operators, we will look at different available arithmetic operators, how to use them in Java, and how to write programs using those arithmetic operators. So let us look at our next video on chapter 7, arithmetic operators.